For this question, you need to understand what a discriminant is and how it helps you distinguish between the different types of roots that you can get. So namely like whether a graph has two distinct and two real and distinct roots, two real and equal roots, or no real roots. Okay, for the first case, your discriminant has to be more than zero. For the second case, discriminant equals to zero, and for the last case, discriminant less than zero. So why the graph will look the way it does for each of the cases, I won't explain in this video, so I will assume that you already understand why. Okay, and you also need to know that the coefficient of x squared will determine whether the graph looks like an N-shaped graph or a U-shaped graph. Okay, so to find the range of k for which this is always positive, okay, this equation is always positive where k is a constant. First, you need to recognize that this is a quadratic equation, right? Which means it will look like a curve. So yeah, I hope you understand how to distinguish between linear graphs, quadratic graphs, and like cubic graphs and other graphs. Okay, so just very quickly, okay, the first graph is linear. Okay, you can tell because the highest power of x is 1. For the second graph, the highest power is 2, so this makes it a quadratic graph. For the last one, the highest power is 3, so this makes it a cubic graph. So the first graph is just a straight line, linear, right? Second graph will either be U-shaped or N-shaped. For the cubic graphs, they generally take this kind of shape. Okay, so since you know it's a quadratic graph, right? For the question, for this equation to always be positive, okay, it must be a U-shaped graph that lies above the x-axis. So why must it be U-shaped and why must it lie above the x-axis? Imagine if it's an N-shaped graph, okay, and it lies below the x-axis. This makes the entire graph negative because it's below the x-axis. When they say always positive, right, okay, you might wonder whether it's positive horizontally or positive vertically. If you look at the x and y axis, right, okay, you might think that this side makes it positive, right, because all the x values here are positive, okay, but it could also be positive in the y axis because all the values here are positive in the y axis. Okay, this equation, right, this whole thing equals to y, right? Normally when you have an equation, it's y equals to this whole equation. So when you sub different values of x in, right, the result will be your different values of y. So they are saying find the range of k for which y is positive. Therefore, you want your graph to be positive in the vertical axis. That means everything above the x-axis, right? So I hope this makes it clear why you can only have one scenario for this, right? It can't be n-shaped because even if your n-shaped graph lies above the x-axis, right? This kind of graphs extend infinitely, right? So eventually you're going to have a portion of your graph that lies in the negative portion, right? Which is not what you want. It has to always be positive. So the only way this is possible is if it's U-shaped and it lies above the x-axis. Even if it's touching the x-axis, this is not considered always positive because there's a single point down here where your value of y is 0 and 0 is not positive. Okay, so you start with that, right? It has to be U-shaped above the x-axis, and that's how you come up with like your two conditions, right? The equation needs to satisfy two conditions. One, it needs to be U-shaped. What determines whether it's U-shaped or N-shaped? The coefficient of x squared, right? In this case, it's k. K has to be positive, right, for it to be U-shaped. Because remember, if k is positive, it's a smiley face. If it's negative, it's a sad face. Okay. Second condition, cannot have any roots, right? So for no real roots, your discriminant has to be less than 0. Okay. So let's go ahead and find our discriminant. Discriminant, remember, it's b squared minus 4ac, right? So identify your values of a, b, and c. A is k, b is 2, and c is 4k. A is the coefficient of x squared, b is the coefficient of x, and c is the constant term at the back, right? That doesn't have any x term inside. Okay, so just subbing those values in. Okay, your discriminant has to be less than 0, right? Our b is 2, value of a is k, and c is 4k. Okay, so 4 minus 16k squared has to be less than 0. Yep, so to resolve this inequality, right, you have to be familiar with how to resolve quadratic inequalities also. Okay, to solve quadratic inequalities, right, you need to sketch the curve. Okay, this is the equation of your discriminant, right? discriminant equals to, let's put a k square term in front, negative 16k squared plus 4. Okay, what does this look like to you? Okay, it actually resembles a quadratic equation, right? It's like y equals to negative 16x squared plus 4. See, the highest power of x is 2. This is a quadratic equation, right? So if I replace the y with the word discriminant, okay, and the x squared I replace it with k squared, that would mean that I can actually sketch a graph that represents my discriminant, right? Hang on. Okay, so instead of the y-axis, I'm going to place the discriminant on the vertical axis, and instead of x on the horizontal axis, I'm going to use k, right? So negative 16k squared plus 4. This is an n-shaped curve, so my curve is going to look like that, right? I remember I need my discriminant to be negative, so a portion of my discriminant is positive and a portion is negative, right? The negative portion is this part here, below the k-axis, right? Same reasoning. Below the x-axis, the vertical axis describes my discriminant, right? For my discriminant to be below 0, it needs to be below the horizontal axis, right? Just think of this as something like a sunrise, right? The sun at this point is below the horizon, at this point is on the horizon, and then it's above the sea, and then it eventually sets again. Okay, so I need to find this time, right, where the sun is exactly on the horizon. Okay, so that's how I can describe the range. Like, for example, if this is like 10 a.m., this is 2 p.m. or 5 p.m., right? Uh, sorry. Eh? Yeah, 5 p.m. Then I can say that my discriminant is less than 0 when k is, you see, when it's before 10 a.m., right? When k is less than 10 a.m. or k is more than 5 p.m. That's how I describe the ranges for which my discriminant is less than 0. Okay, but yeah, of course it's not 10 a.m. and 5 p.m. To find those values, right, we need to go and find the roots of this discriminant curve. So notice, this, I have two graphs here, right? The graph on top is for my original equation. Okay, this graph below is for my discriminant. The discriminant has its own graph. Okay, you need to be very clear that there are two graphs so you don't get confused. All right, the original graph cannot be positive, cannot be negative. It has to always be positive. My discriminant is not always positive. There are portions of it that are negative, there are portions that are positive. Okay, so how do we find the roots of the discriminant? Yeah, our discriminant is 4 minus 16k squared, right? We found it over here. Okay, so to find the x-intercepts, your y has to be 0. Remember, if you have to write the coordinates, right, the y coordinate, in this case the discriminant, the value of y in this case is the discriminant, right? It has to be 0 when it's along the horizontal axis. So you sub this equals to 0 and then find the values of k, right? How do you do that? You factorize this, okay? This is like, you use special identities to factorize. Okay, a squared minus b squared, right? So using special identities, you can write this as 2 minus 2k, 2 minus 4k times 2 plus 4k, right? Because this times this equals to 0. Okay, for those of you who don't remember like your zero product rule or null factor theorem, right? If a times b equals to 0, okay, that would mean that either a is 0 or b is 0 or both are 0, right? So that applies here, okay? So either 2 minus 4k is 0 or 2 plus 4k is 0, which means that 4k is 2, k is half, or 4k is negative 2, k is negative half, right? So this gives me my two values here, right? Negative half and half. Okay. So how do we describe the portion where my discriminant is, sorry, the range of k where my discriminant is negative? That would be, remember the sunrise and sunset analogy. The discriminant will be negative when k is less than negative half or k is more than half. All right. So yeah, remember this is the second condition where my discriminant is negative, but I have two conditions, right? We can illustrate both conditions on the number line. For my discriminant to be negative, okay, it has to be either less than half or more than half. We're talking about my values of k, right? This is the second condition. The first condition is if I want my original curve to be U-shaped, right? My k has to be positive. K has to be more than 0. So that will be described by this arrow here. Okay. So both criteria has to be fulfilled, right? Which means that I have to be looking at this range because any value here satisfies both conditions, right? For example, if my value was here, let's say this is like 1/4, right? It will only satisfy condition 1. So my graph will be U-shaped, but my discriminant will be positive. That would mean my graph will look like that. Okay, it's not always positive. There's some of it that's negative. We can't have that. If my value is here, for example, negative 1/4, that will mean it's neither U-shaped and it has two roots. So it'll be N-shaped, uh, and a portion of it will be above the x-axis. Okay, so my final answer should be k has to be more than half. Okay, we have to recheck k less than negative half. All right.